This is the Math 1401 Zoom meeting for Thursday, March 11th. We're doing section 6.1 today, 12 p.m. Zoom meeting. So we'll walk through some problems from page 305. Why don't we try one like number 7? And the directions are: decide if this is discrete or continuous. The random variable is discrete or continuous. State possible values of the random variable. Part A, amount of rain in Seattle. Well, there isn't just 1 inch or 2 inches or 3 inches. There can be 1.5 inches, an 1 3/4, 1/10 of an inch. Yeah, so clearly that would be continuous. And your amount of rain, you can call it I guess they just use X, and you can say it's greater than or equal to 0. That's all you have to say. B can be any amount bigger than 0. Presumably you wouldn't have a negative amount of rain. Let's see, number of fish caught during a fishing tournament. Well, there's really not half a fish or 1.5 fishes, so we will call that discrete. And I guess we'll have the X is the number of fish, and you can catch 0 fish, 1 fish, 2 fishes, and it really is no maximum number. It just kind of goes. All right. C. Number of customers arriving at a bank between noon and 1 p.m. Clearly there's not half a person out there, so that would be discrete. And once again, 0, 1, 2, and it would go on. There's theoretically no maximum, although the fire department would probably set a maximum number, but we don't know what it is, so we won't list it. And D, time required to download a file from the internet. That would clearly be continuous. I guess we'll use T for time. And again, it would be some time greater than or equal to 0. That's all you have to put. You don't put 1 because it's not exactly 1 hour or 2 hours or 3 hours. Well, in fact, they leave off the equal to. If you look at the answer, technically, I guess you can't download a file in 0 time. So I guess technically it should be just strictly greater than. T greater than 0. Some positive time greater than 0. Oh, we have a participant, Ms. Obeys.
Good morning, sir.
Good morning. And how are you doing this morning?
I'm good, thank you.
Okay, yeah, I was just working down through some problems. Did you have any questions you wanted to ask?
Yes, please. I have a question on my lab.
Okay.
My lab, the part D for 6.1.23. I was unable to do it.
23 part D, all right.
Yes, please. And then also 6.1.25. Okay. I was unable to do it too, so I need help.
Can you feed me the problems? Read them to me or whatever. I don't have them in front of me.
Can I pull it up, please?
Yeah, sure thing. Go ahead and pull it up.
Okay.
Hey, while you're doing that, let me work another example of one I didn't do Monday. And then let me know when you're ready, okay?
Okay, thank you.
Sure. How about page 305, number 9? And the idea is decide whether this is a discrete probability distribution, statewide, which means if it's not, it violates one of the rules. All right, let's see, I can list it 0, 1, 2, 3, and 4, and they're equally probable, all 0.2. And so this would be an example of a uniform distribution, everything equally likely, equally probable. And so is this a valid distribution in effect? Is valid distribution? Rule 1, do all the probabilities lie between 0, P of X, 0 and 1, and clearly they do. 0.2 lies between 0 and 1. And number 2, sum of the P of X's equal 1. Clearly, yes, it does. 0.2 plus 0.2, 0.4, 0.6, 0.8. 2 is 1, yes. Okay, so they give you a whole bunch of those. Have you got it pulled up? Or are you still working on it?
Okay. Okay, I pull it up. So, hello.
Yeah, I'm here.
Yes, please. So, question 6.1.23.
Okay.
Yeah,
Part
it's
B.
talking about, they say, interpret the mean of a discrete. So, it has a graph, it has a chart. It has a chart. The chart says, the question says the graph of the discrete probability to the right represents the number of live births by a mother 50 to 53 years old who had a live birth in 2015. Complete part A through D below. So we have this chart. The chart says, number 1, we have 0.
Okay, this is really simple.
0.239.
Okay. I'm
Number 2, we have 0.264.
okay.
Number 3, we have 0.167.
Okay.
Number 4, 0.111.
Okay, just a second. I'm not writing your numbers down. I've pulled up 23 out of the book. Can you see it on your screen?
23. Okay.
So it's really similar to this, but your numbers seem they looks like they've slightly changed these numbers. Is that correct?
Yes, please. So the problem I had is question D, the D part of it, because I got the A, B, C, but I got stuck with D.
Okay. Is it the same question here? 50 to 54-year-old mama who had a live birth is randomly selected. How many live births would you expect the mother to have had? Is it the same question?
Okay. Please, can you take the question again? The heading, please.
Is your part D the same as this part D?
Part D says, okay, let me go back, please. It won't take me to part D. Let me just put any answer and then try to walk through part D.
Okay.
Okay, part D say if a 51 to 56-year-old mother who had a live birth in 2015 is randomly selected, how many live births will you expect the mother to have had?
Okay. I need
Yes.
you to go ahead and, yeah, read me the numbers because so we'll use your numbers. I'll make a little table here. And so X is the number of births. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And give me the numbers on the top of those lines in your problem.
Okay, the numbers end at 8. We have 8 numbers. So number 1 is 0.236.
Okay.
Number 2, 0.280.
Okay.
Number 3, 0.164.
Okay.
Number 4, 0.111.
Okay.
Number 5, 0.099.
Okay.
Number 6, 0.031. Number 7, 0.034.
Okay.
Number 8, 0.045.
Okay. Is that accurate? That's what I heard.
Hello?
Yeah. Is this good? This is what I heard.
Yes, that is what is on top of the chart. That is number 1 to 8. The chart is 1 to 8.
Okay.
Mhm.
All right. So the key to this is the word expect.
Yes.
Okay. There's a phrase called expected value, which is identical to mean. They're really telling you to find the expected value, which equals your mean.
Okay.
And we showed you the scheme on Monday. You need to sum x times p of x. That means you have to go, say, 1 times your 0.236. That's your x times the p of x. Then do it for the next row. Add up 2 times 0.280. And keep going. Now, this is sort of the by hand long way. Do you want to enter the numbers in the calculator and I'll show you the short way?
Yes, please.
Okay. So on the calculator, you go to stat mode and edit. We're going to erase both columns. And just like you'd write it on paper, this is your L1 and this is your L2.
Yes, please.
Okay. So one's pretty easy. 1, 2, 3, 4, 5, 6, 7, down to 8. The L2 will be a little longer because you got 3 digits. 0.236, 280, 164, 111, 099, 031, 034, 045. Are you entering them along with me?
Yes, please.
Okay. Now, are you ready to go on? Or are you still entering?
Still entering. So, if I may ask, it means it is 1 times the P, right?
The X times the P. So yes, 1 times 0.236.
Okay. So you add from 1 to 8, right?
No. You take each X times the P of X. So you got to divide by the number of numbers.
Okay. That is where I got it wrong because I didn't divide by the number.
Well, you don't really. When you multiply by the P, you are dividing by the number of numbers.
Oh, okay.
So this is the first 2 rows, then your next row would be 3 times 0.164. Then 4 times 0.111. And you've got to add all this.
111.
Yeah.
Yes.
You got 4 more to go. 5 times 0.099.
Plus 6.
6 times 0.031.
0.021.
7 times 0.034. 8 times 0.045.
Okay.
So yeah, if you want to see it done this way, it's written out. 236 plus 2 times 280 plus 3 times 164. I'm going to hit enter. So the first 3 of them add up to this. Then I'll keep going. 4 times 0.111. 5. Are we going too fast? 5 times 0.0.
No, please. It's okay.
Okay. Plus 6 times 0.031. Plus 7 times 0.034. Plus 8 times 0.045. That should be it. I hope we get it all in right. 3.011 for this number, for these numbers.
Okay. Is this the answer of Part D, the 3.011?
Should be the answer, yeah. Now, I don't know if they make you round it back to 3, because obviously you can't have 0.011 of a kid, but
Okay, let me check this.
you might try the 3.011 first.
Okay, the answer say round to 1 decimal place.
All right, well, that would be 3.
As needed.
Yeah,
So it'll be 3.
This 3 is rounded to 1 place, yeah.
Okay. Thank you.
Uh-huh.
Then the second one is 6.1.25.
Okay, I've got a similar problem here. Maybe
Okay.
your notes about life insurance.
Let me check this.
Okay.
Yes, please. About the life insurance company. Yeah.
Okay. Why don't you give me your numbers, because they're probably different from mine.
Okay, my number is, we have, suppose a life insurance company sells a 230,000
Okay.
dollars 1 year. That is $230,000
Right.
1 year.
Okay.
That is 230, and then 000
Okay.
1 year.
Right.
1 year term life insurance policy to
Right.
a 32-year-old female
Okay.
for $170.
All right.
Full stop. The probability that the female survives the year is 0.999474.
Okay.
Full stop. Commute and interpret the expected value of this policy to the insurance company.
Okay. It's the same idea. They want the expected value, which is mean.
Okay.
But to find it, we're going to have to create a table.
Okay.
And are these numbers right? This is what I heard. I
The
froze.
numbers are, the first one is 230,000.
Okay.
Then the second number is 170.
Okay.
The third one is 0.999479.
479.
Yes, 479.
479. Okay, got it.
And sorry, 474. Sorry.
474. Yeah, no
I'm
problem.
sorry.
No problem.
0.999474.
Okay.
Thank you.
I don't know how much you know about life insurance. It's incredibly technical and very complicated. But I don't know if you have any life insurance.
Yes, please.
Okay. But in any case, yeah, you can go to a company and take out a policy. It's basically a contract
Okay.
that says if you die, they will pay your beneficiaries so much money.
Yes, please.
For this example, you're going to pay them $170. That's called the premium.
Mm-hmm.
And then if you happen to die over the term of whatever the policy is, they're going to pay your beneficiaries $230,000.
Yes, please.
So the idea is they're going to collect a lot of money from a lot of people, a lot of these $170. Enough, and the probability of you dying is pretty low over the period. But you want to be protected. You could have a car wreck. You could have get cancer. Something. You're just trying to protect yourself. And so they've collected enough of these premiums so that they can pay out the $230,000 and still make money to the random person who does happen to die. You get the basic idea?
Yes, please.
Okay. So we're going to create a table for this. It's going to have 2 rows. X is the gain to the company. Gain to the company. And then this is probability, P of X, probability. There's really 2 cases. Our person lives, or God forbid, they die.
Okay.
Okay. Now, you can think of this as having 4 pieces, 4 cells here. A couple of them are pretty easy. The others, not so much. Okay. This is an easy cell right here. If our person lives, they told you the probability of that happening right here.
Okay.
0.999474. Okay. How much did the company gain if you live? Well, they gained what you pay them,
Okay.
the $170.
170.
Right. Questions about that?
No, please.
Okay. This is the bottom row is what's tricky. Once you get the table, the problem is really straightforward. It's exactly like the last problem. You know, this times this plus this times this. But the trick is getting the correct numbers in this table because they only gave you 2 of them and you've got to puzzle out what the others are.
Okay.
Okay. Let's say, God forbid, you die.
Okay.
That means that the company gained your 170 because you paid it to them. But then they're going to pay out the 230,000.
Okay.
So it's going to be 170, but then they lose the 230,000.
So it is 170 minus 230,000.
Yep.
230,000.
Yep.
Okay.
Negative 229,830.
Okay.
Okay. Well, what is the probability of that happening? Well, that's where the complement, remember the idea of a complement coming in? If this
No,
is,
please.
no, a complement was the other thing that can happen. If this is the probability you live, how do I get the probability you die?
That should be 1 minus the probability of 1 living.
Well, very good. We've got another participant. Thank you so much. Absolutely. Yeah, it's going to be 1 minus the 0.999474. And you better keep all the digits if you want it to work out. So 1 minus 0.999474. And I hope you know how to interpret this. This means move 4 places left. That's going to be 0.000. You have 3 zeros and a 526. Okay, question. See, neither of these 2 numbers were given in the problem. You had to puzzle them out.
Yes, please.
Now that you know them, it's really straightforward. This mean now is the same game. This times this plus this times this. They called it expected value. Take 170 times its probability, 474, and add negative 830, sorry, this times this, times 0.000526. I hope y'all can read that. All right. And so that's 170 times 0.999474. And you can either subtract, if you want to subtract, that's fine, or you can add negative 229,830 times 0.000526. $49.02. That's the company's profit for selling these policies. That's the average amount that they make for selling these policies to a bunch of people. They make $49.02 per policy.
Okay, thank you so much.
Sure thing. Anything else? Our new participant, is it Mr. Augustine?
Yes.
You have any?
Good afternoon, Professor.
Okay, yeah. You have any questions for us today?
No, but I love the ones you've solved so far. They are
Okay.
They are really nice. They help.
Okay. Is there anything else in the book that we could help you with? Did you figure out the blackjack problem? That's a little more straightforward because they give you the table.
Yes.
You figured it out, so you don't need to see that one?
No, no, please. I would love to see.
Oh, okay. Well, you get a blackjack lesson. Just don't forget, playing blackjack for money in Georgia is illegal. So we are giving you lessons in illegal activity. I don't know anything about blackjack myself, so this is, I don't spend my time in all our open Georgia casinos.
Which the probability is equal to 0.
Right, exactly. Yeah, exactly. Now I could go to a casino right down the street in Georgia anyway. Although you can go to Harrah's. You know where, Harrah's up in North Carolina? You ever heard of it? Seen the billboard?
No.
Okay, the Cherokee Indians have a reservation in Cherokee, North Carolina. It's probably 3 hours from here. And they've got a huge casino. It's called Harrah's. And they use it to make money for their tribe.
Wow.
A lot of people from Atlanta go up and, play. It's the closest casino you're going to find. Okay, so it's a popular game. Player dealt 2 cards. I don't know if you want to know all these details about blackjack or not. Where the card, of course, go ahead. The value of the card corresponds to the number on the card. Face card's worth 10, aces are worth 1 or 11. The object is to get to as close to 21 without going over and have cards whose value exceeds that of the dealer. Blackjack is an ace and 10 and 2 cards. It pays 1.5 times the bet. I didn't know that. Did you know that? Aren't you so glad you showed up today and paid your tuition money to find that out? The dealer plays last and must draw a card with 16 and hold with 17 or more. Following distribution shows the winnings probability for a $20 bet. In cases where the dealer and player have the same value, there is a tie. It's called a push. Oh, they give you the source. So, somebody studied this and published papers about this. All right, well, then they give you these tables, this table. Notice how high the probability is of losing $20. That's the highest chance, is losing $20. All right, compute and interpret the expected value of the game. And you expect to be dealt 40 hand. Okay, so it's pretty straightforward. I'll recopy the table here real quick. Page 307. Your winnings, problem 27. Page 327. Your winnings. All right, so they're talking about 0, win 30, win 20, or lose 20. The probability of that happening, 9% chance, so 982, you win bupkis. 0.0483, 4% chance you win 30, 0.389275, you win 20, and 0.46225. And so I just copied down those numbers. They figured them out for you. And so, part A, your expected value, I'll write it out. Same game, 0 times this, plus 30 times 0.0483, plus 20 times 0.389275, and plus negative 20, 0.464225. We just punch away. Don't have to punch the first one because it's just 0. So I'll start with 30.0483 plus 20 times 0.389275 plus negative 20, or you could subtract 20, either one, times 0.464225. Thumbs up, a nickel. Negative 0.05. You understand what that means? This is your average winnings. I'll put the winnings in quote because what's the negative winnings? Because
It
what,
is lose.
yeah, because what does the negative sign mean? Right.
Once you there, you have more chance of losing than winning.
Exactly. If on the average, with these probabilities, every time you play the game, you're going to lose a nickel. Now, yeah, some games you do win, but they're balanced by other games you lose, and it averages out to be a nickel per game. So then in B, in the course of an hour, you can expect to be dealt about 40 hands. How much should a player expect to win or lose over 3 hours? So an hour is 40 hands. 1 hour is 40 hands. All right. So 3 hours, you'd be at what? 120 hands, right?
Yes.
So you would expect to lose
128 times negative 0.5.
exactly 120 times negative 0.05. Negative $6. You expect to lose $6. I don't know how much you all keep up with basketball players. Y'all have heard of Michael Jordan?
Yes, please.
Okay, he's one of the, regarded as almost one of the greatest basketball players of all time. He's been retired for 20 years now. Yeah,
I've met him once.
Yeah, I was reading an article. Did you meet him once?
Yes, I met him. I went to his restaurant in Chicago.
Oh,
Oak Brook in Chicago, and fortunately for me, he walked in.
wow.
So, yeah,
All right.
that is huge. The TVs doesn't do him any good. He is, he's a giant.
Yeah, I was reading an article about him a couple days ago. He's a big gambler and he likes blackjack. And the article was about a night he was in a casino, and I think he got down 500,000. He had lost 500,000, but he kept. This was by like 1 a.m. He started playing about 7 p.m. He lost like 500,000 by 1 or 2 a.m. He kept winning because he doesn't like to lose. And doggone, he kept winning at it, and he had recovered and wound up 500,000 to the good. Like 7, 8 a.m. in the morning. But you understand, those numbers are just, I can't comprehend them, but they're toilet paper money to those guys.
Yeah.
It's just 500,000 is nothing to them. They've made so much money.
Yeah.
It's amazing. But yeah, he like turned it around like $1 million. It's absolutely amazing. Is there anything else I can help you with or ask questions, answer questions?
I had this, it was a test question. So I texted it to you, but I don't know, I didn't have a reply.
Yeah, I'm not sure. I tried to reply to you, but I didn't really have all the details, so it may not have. You want to try again?
That was question, that question was question, I think it should be question 13. 13. It was point, I think point 11997.
Okay, I've got the test 3 form in front of me. Which question number was it?
I think it was question 13.
10?
13.
13.
Yes, please.
Okay. Let's see if I can find it here. Okay. So you were wondering if the problem was worked correct? This is test 3.
Yeah, because from the working, when you arrive to the answer doesn't tells you that it tells the answer is wrong, but the working, I think the working is okay, but the answer that I saw there, I think it wasn't the answer. So I don't know.
No, I think the working is wrong because I realized that although you put it in a way that it's a little bit like it's corrected, but that is 38. It's supposed to be 39.
Exactly.
So that makes the difference. So it should be a false.
False.
It should be false. That is correct.
I was looking it at as 39. I was not even looking it at as 38 because at the end it shows that it was 39 because when you take 40 times 39, it gives you 150 something. I think 156. So I was confused also there because I wasn't looking at it as 8. I was looking at it at 9. But then when I arrived at the answer I saw that was wrong. So I had to put false.
Right. This should have read 182 over 1520. If I was going to, okay, this is wrong. This should have been 39. That's what's going to make the whole thing false.
False, yes.
Yeah.
That's it.
This number should have been 1520 based on this. So I screwed that up. And then I'm sure I've screwed the decimal up. The decimal for this should have come out 182 divided by 1520. Should come out 0.1197.
Good.
Which it did, didn't it?
It did. 0.1197.
0.1197. But that's wrong because the correct this is wrong. If you want to compare it to 14 I did correct.
Yes.
No, it was just 13. It was 13.
Right. 14 should be true because
Yeah.
there was 9 max fleas. Yeah, 9 over 40. And then there was 7
Yes.
flights.
14 is true.
Yeah, 14 is true.
Yes. 13 is false because
13.
I write everything. Everything I enter is on my is down. Then 18, number 18.
Okay.
I had issue with 13 and 18. So like, is it right? Is it
No,
true? Is it false?
18 is false as well.
Thank God.
Got it right here. 0.21. There's 5 of these people, or probably 5 of them will have a DUI. So that's 0.21 multiplied by 5, multiplied 5 times, 0.21 to the 5th, but 0.21 raised to the 5th is 0.000484. See, it's much smaller than I'm showing here. The 0.21 to the 5th is correct, but I wrote the answer down like this. This is not this.
Which makes it false, right?
You omitted two zeros after the point, which is significant.
Exactly. Missing 2 zeros here, which, yes, is significant. You're off by a factor of 100.
Yes.
Yes.
And so I did this correctly based off this answer, but this answer is right. Of course, this doesn't have, remember we said if even one part's wrong, the whole thing's wrong.
Yes.
Yes.
So it doesn't really matter that I did this off of this. I mean, this, it's correct, but this number's wrong. So this is the wrong answer down here. But it doesn't really matter because A is wrong. That's all you need.
Okay. Thank you.
Professor, when we stop recording, I'll have some questions.
Okay. Well, go ahead.
Okay, Professor, I realized that from these exams, they've been quite okay based on your teachings, which is quite okay.
Uh-huh.
My exam 2 was a horrible experience for me.
Okay, let me stop you. Are you going to go ahead and you want to get in and talk about your personal?
Yeah.
Yes, that's, I mean, if we
Okay.
stop.
Yeah.
Should I go? Should I mute? Should I go off?
No, you can, it's okay, ma'am, you can stay.
Are you sure? It's
Just that,
personal.
yeah,
No,
it's just the recording that I
honestly, I really can't do that. I really need to send you a separate link and have our own little private video link. And I'll be happy to do that. Are you ready for that?
Yes, Professor.
Okay. Ms. Sobeys, do you have any further question, more general question?
No, please. No, please. I'm good to go. Thank you so much.
Okay, well, sure thing. Well, I will, we'll end this session. We'll have another one at 8 p.m. tonight.
Yes, please.
If anybody wants to come out, I got more questions.
Okay.
And yeah, I will end this session and I will send you a separate link.
Thank you, sir.
Okay, sir. Thank you so much.
Yeah, sure thing. Take just a couple minutes. Just stand by. All right.
Thank you.
Sure thing. See you maybe at 8 p.m. tonight. We'll see.